Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and Fred has promised to ask an amazingly sophisticated, academic, theoretical, yet practical question.
No.
No.
It is a good question, and it's kind of generic. Right. I think it'll apply to many of our listeners at one point in their careers or another. The question was very simple. It was that she asked, how does one get started with shock and vibration testing? And I thought, it's easy. Just shove your product off the desktop and see if it survives. And that you're a lot further along than most companies. My other piece of advice to her is, realize that the standards are the lowest common denominator, agreeable situation for the group of people that signed up to go work on it, on the standard. So be careful of those. It's a starting point, but it's not always what you need for your product. Mm-hmm. And then it was, well, why do you care about shock and vibration? Is it transportation? Is it, the way your product's used? You just moved into mobile products, for example, or, what is it? What's the motivation for this? Why is this an issue? Is that you had a spare corner in your lab and you got a vibration table, or is it some purpose? And so I didn't get really a lot of answer off of that from my first response to him. So I don't have any more context, but how do you get started with shock and vibration testing?
Knowing what the customer wants and how they're going to use your equipment, probably be the first thing. Yeah. I mean, it's all well and good. I mean, we know that mobile phone manufacturers do lots of shock and vibration testing.
I saw one of them used like a cement mixer. I mean, it was literal cement mixer with paddles in it, and they would throw a handful of phones in it and tumble them. And it'd be like for an hour, and they'd still have to work coming out of it. And like, wow.
But they'd be able to tell you why.
No, they didn't. I asked them that. I asked them, well, why do you do that? This is, do you have a lot of phones fall into cement mixers and they forget about it for an hour? How does that relate to anything in real life?
But they're trying to replicate clearly the way some customers abuse their phones. When I say some customers, I mean my wife.
Yeah. You have a daughter. Does she have a phone yet? Has she broken her phone twice yet?
She's 11. She hasn't broken anything with the frequency that my wife breaks it. Now, I'm always trying to get her to get big, chunky phone protector, but they don't look good. So she doesn't want to get them, but I'm just saying, you know what? It looks so much better than that smashed screen you always carry around anyway. So
yeah, you're not going to win.
That's a different problem.
Chris. Yeah, you're not going to.
No, I'm none from a million right now. But anyway, but you might not be able to join the dots perfectly, but based on speaking to the technician, but I dare say that cement mixer thing is not a standard test. Would that be a fair call?
Oh, no. That's kind of where I come down with one of the standards that's out there, and I see it in all kinds of products, is 10 random drops onto a wooden floor or a concrete floor or whatever. Sometimes it's rock or whatever. And if it passes that, it's good. I says, hold on a second. Good for what? For 10 random drops and that's it? What if it fails on the 11th one? Is that cause of an alarm, or we pass the test? And I ran into too many clients to say, well, we passed the standard, so we can list it on the data sheet, and it's passed. Hang on. How is your product actually used? And what kind of field data do you get back? What kind of damage do you see that you can replicate by dropping it for 3 feet onto a carpet? What? I agree with you. Is that well, how is it used? What are the stresses it's going to see? Is it shipped by truck with no shock absorbing systems in it at all, loosely in a big pile in a big box all loose, no protection whatsoever, and they rattle and bang and crash into each other as they go every pothole in the US, or not. What is the set of stresses that you're interested in? Now, even given that, in trying to replicate some of those and measuring those things and going deep into different kinds of vibration systems and different ways to replicate what your customers are experiencing it. I had one that said, do we put a lanyard on this or not? And a lawyer got wind of it and says, no, don't do that, because then you'll break risks the way and there's lawsuits with things with lanyards on it, breaking wrists. When somebody falls and the product works as a lever, and it's not good for your wrist. And I said, well, why were you thinking of putting a lanyard on it? It says, well, the first prototype, one of our customers picked it up and promptly threw it into the wall because it wasn't a good enough grip on it, and it shattered. And it's like, well, the lanyard would stop that from happening, but do you ever think that it might just swing right up into their face instead? They're like, we got to think this through. So they ended up making the product a whole lot thicker. So it was more like a baseball bat get thrown on the wall, and the wall got more damage than the product did. So that's the way they solved it. But it's the thing I run into, and I've looked and I've taken a couple of classes from on him. John, I can see his book. It's a small red book. I'm drawing a complete blank on his name. Steinfeld, Stein something. And I know he passed away, maybe 10 years ago or so, and he was pretty old, but he was kind of the go-to vibration guy in matching what the field is to how you replicate that in the lab. That was his thing. And his books, and even talking to him, it was like the ability to say, oh, if I put it on this vibration with this amount of energy and this, this circumstance, and it works to mimic, 10 years of actual use. If you change one rivet on that structure, that relationship may likely be different. He says it's near impossible to say, if I shake, rattle, and roll something, that it's good for 10 years. There's no fixed recipe to say that that's true. And I mean, there's other things like if it's a chemical diffusion process, for example, and we control the temperature or what it's being done, we can use some basic chemistry to say, oh, we have a relationship between temperature and the rate of it occurring. And if we can accelerate it, we can, with some caveats and some things you got to be careful of, yet we can do that. Where with vibration, that's not always true. There's too many other variables and harmonics that kick in, and ways vibration transmits itself and across a structure, and all those things make it really, really complex to do it. So his advice basically is understand the stresses you're seeing and put a lot of margin on it. Avoid harmonics. Avoid those at whatever you can do to avoid those things. And so somebody getting started in it is like, well, you could pursue, postdoc degrees and spend 20 years, experimenting with all the materials and structures that you're dealing with. And then you might get a pretty good idea. But that's not really a viable way to say, how do I get started with this? So,
well, the other thing too is that cement mixer test you saw. That sounds like it could be pretty useful, potentially, I should say. HALT test, if you want it to be treated as a HALT test.
Yeah.
Put them all in there, pull them out, see where they broke and how, and
yep. And I don't know if that was the purpose of it or not. They didn't have a way to relate it to real life. So it was more HALT-ish in its concept. Yeah. And HALT
nothing wrong with that.
Nothing wrong with that. I think HALT also a really good system. And it helps design teams to make something more robust, which is in general a good thing. But I've run into others where, and I've told this story, I don't know how many times on the show, is the guy sitting across from me when I was at Hewlett Packard was the packaging engineer. He was kind of the corporate packaging guy. And so he consulted basically with different product lines and divisions to improve their ability to ship a product without it getting turned into dust on the way. And what he routinely did was instrument packages for vibration, for temperature, humidity, all kinds of stuff. He had a little 10-channel multimeter type recording device that had all these sensors hanging off of it. And he said the hardest part was figuring out where to put this box such that it wouldn't change because it has some mass, and it's putting it where it would minimize its effect on how the package is seeing the shocks and vibrations it would see. That was the biggest challenge that they had. And so but he was able to, I mean, he was on the phone one day talking to UPS, I think it is, or FedEx or somebody, saying, did you change the height of drop from one conveyor belt to another conveyor belt in your Nashville warehouse? And it was probably a stunned silence on the other side. And he explained,
because of course they had, I'm guessing.
Yeah, of course they did. And he knew, he's tracking and he's got time hacks and stuff. And they just scanned it when it has arrived. And then a few minutes later, it was scanned and put on a truck or on another airplane or something. And so he knew it went through that distribution center. And he saw, instead of a 1 foot drop, he saw a 2 foot drop. And he says, that's the biggest shock that our products see is in that process. And you're asked, if that's the way you're going to do it, and then we have to add a whole lot of expense to our packaging to survive that much difference. And he didn't say it, but I'm quite sure the other side was going in, and they're going to sue us because now we're damaging their products, kind of thing. Yep. But it was a major investment to routinely, and every week he had something instrumented and being shipped. He knew the temperature of the upper rack of a UPS truck in Arizona. He knew, he knew all kinds of stuff, where our products were and what kind of conditions they were in and stuff like that. And then shared it within the company so that if you were looking for what are the stresses that your package will see, whether it's forklift moved or consumer product or whatever, he had the numbers and all this stuff. And it was invaluable because we found that almost no standard related to shock and vibration came even remotely close to anything our products were actually seeing. And so we were able to accommodate that and create product or packaging anyway for the products that minimize the damage they were going to see in transit. And one way to get started is, I think, right what you talked about right at the start, Chris, is, well, what stresses and shocks and types of vibration and sources of vibration are you experiencing or you expect your product will experience? Start with those. But you're not going to get a magic bullet saying, if I rattle it for 3 minutes left and right, then it's good for 10 years. I really doubt it unless you do a whole hell of a lot of other work.
That's right. It's the same. I think we have a similar sentiment when people say, well, I've done Halt testing. So how long will my product last for now? Nope. That's not what Halt testing is all about. So, I mean, if you're doing vibration testing as part of a Halt serial, awesome. That's fantastic. But again, there is no even with, let's call it standard Halt testing. And I even when I say standard Halt testing, again, you can't see the air quotation marks, but PCB Halt testing, printable circuit board, I'd argue is as close to standard Halt testing as you get. It's done a lot. Everyone knows why, and blah, 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 blah. But even then, you still sit down with your Halt technician and say, how are we going to attack this one? What are we looking for? What's concerning us? So even PCBs, which are about as standard as you can get for vibration testing, the organizations who do it seriously, they still sit down and, of course, if the PCB in question is very similar to a previous PCB structurally, so I will just use that test profile. That's fine. Yep. But if you've got something brand new, even though it's a PCB, you say, okay, what are we going to do to try and get to the bottom of this one?
Well, I started asking for finite element if we really are concerned about vibration or shock, I had one product. It was a handheld device, a game controller, and one of the actions that it was designed to sense was clapping. So you hold it in the device in one hand and you're clapping. It's like a microphone, and you're clapping to the beat, and it would sense whether you're on beat or not. It was kind of scary that way. And I like, wait a second. The circuit board in here is set up like a diving board. You're using one end connector on this thing, and it's 6 inches long. It's just floating inside the cylinder. This might not be a good idea. So we did a finite element analysis, and of course the mechanical engineer said, "Oh, that'll never happen. That does, they don't understand what they're doing, blah, 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 blah." And of course it failed exactly where the finite element predicted it would. Here's the max strain, would be right here. And it popped that component off within 2 seconds. It just poof. And mechanical engineer had to eat his words there and put in some foam, double-sided tape, basically, that's dampened the whole damn thing. But the idea is that what are the stresses that you are expecting to see? And go like in a Halt style fashion is, well, what if it is thrown against a brick wall? What if it's dropped 10 feet? What if it's, be used in a handheld device and somebody's clapping? What if it's as a camera and a cell phone and you're holding it over your head and you drop it? That's not a 3-foot drop. Will it survive? Go through the what if and where's all these sources. If it's a shipping thing, put it in your shipping container and ship it, measure it. Send 20 of them out and see how they do with different routes that they might take, and just try it. It's really hard to equate a sine wave impulse, or square wave impulse on some fixed thing and say, oh, it's good. Because if you move a little bit up or down, or you have a little bit different location where that impulse is being imparted on your device, it might all of a sudden become harmonic. And what I mean by that is it just self-amplifies and just goes crazy. Lots and lots of energy gets generated real quick. And it's the weirdest thing. It could be, if I hit it on the corner, it'll create this amazing, weird vibration energy through the system. But if I move it 1 millimeter to the left or right, and that's where the impulse hits, it's fine. It's just a brick. It doesn't care.
I was running a course recently with people from an organization which did a lot of work with trains. And one of the issues they were facing was that essentially wheels and rails were wearing out faster than any model suggested. And it was down to harmonics. Essentially, the train was bouncing along the rails ever so slightly at that particular turning. Nothing huge in terms of, as a passenger, you wouldn't notice it. But at because I don't know if you know this, Fred, but trains are really heavy, and there is a really incredible amount of stress between a wheel and a rail.
Oh, that's why pennies get so thin when you put them on that rail.
Right. The train doesn't even
don't
know.
Do that. I don't recommend anybody do that. But
no. Right. But it's essentially creating an entirely new set of stresses that no one predicted. Tacoma Falls Bridge, another great example of, we forget about those sorts of things, and all of a sudden that happens. So harmonics, you could even argue fatigue's not harmonics, but it's another example of a failure mechanism where teeny tiny stresses can accumulate to create horrific results over time.
Yep.
You just never know. You can do things like, finite element analysis these days have become incredibly sophisticated to the extent there should be no excuse for not using it anymore. But just to wish harmonics away is very, very dangerous.
Yeah. So the field of shock and vibration is massive, and there's people that make their whole careers out of it. And so to get started was, one, don't rely on the standards. They're, a starting point and give you some of the terminology and a baseline of how different instruments are used. And with the standards often fail to do, and some textbooks are better at it than others, is why you would want to use a sinusoidal type vibration. And it's looking for for harmonic places where all of a sudden your device just rattles itself apart, as opposed to a drop machine, and well, what are you looking for? How do you measure it? And so on. It's one of the many things in hindsight that you and I, Chris, would say, you got to think it through. You got to sit down with the engineers teams and what's at risk and where's the forces and how's it structured. What's the intended use? What's the kind of shipping methods we're going to use? What kinds of loads and stresses is this thing going to see? And then it's which of those have the least margin? Which one of those things has the highest probability of causing catastrophic damage to your product? And then fix those. It's not different from pretty much any other set of stresses. The issue is that just because it passes one kind of stress, say it passes a drop test, for example, it doesn't mean it's going to survive the truck drive, which is a bunch of vibration. The forklift may have dropped it onto the truck and it survives that. But the vibration itself creates a whole different class of damages, the cumulative damage type stuff. So it's think through how these things manifest in your product. And the best thing is to understand those stresses, understand those loads, create margin in your product. And testing will give you some indicators of that, maybe some surprises. And I really do like the HALT style approach as a good place to start. Be warned, there's all kinds of other episodes with Kirk and I on. Is you come out of HALT and the vibration broke this thing, and they say, well, that of course it broke. You overstressed it. Well, it's accumulated damage. You have to have the understanding of the failure mechanism, how it translates to the real world. In order to convince people, you need to go fix this. There's lots of other tactics for that.
It's crazy. I mean, like when people design anything, they'll say, oh, well, even though, we designed it to have a speed of 50 kilometers per hour or a pumping capacity of 30 gallons per minute or what have you. So let's just do a test to make sure we can. It's just, which is, that's admirable. We want to confirm that it's working the way it should. But the same people who can fundamentally understand that, we need to make sure it can run as fast as we think it's supposed to be running, or it can pump as much as we say it should be able to pump, or it outputs the amount of power we believe it should be outputting. We're going to advertise or what have you. Are we going to test how long it's going to last? Nope.
No, it takes too long. It's too expensive, and we don't want to know the answer either. So,
and even if you say, well, of course it broke, you push it beyond its limit. Got it. So why is this different to you testing how fast it can run, how much fluid it can pump? Why are you just throwing this test result away? It's mainly because it's psychology, and failure's got such a negative. All the stuff. Let's just say that.
It was all the stuff. That's another episode, I think.
Yeah.
So anyway, I think we addressed, I do remember one story, real quick story. Somebody asked me, they were making a portable printer, a battery powered little portable printer. And they were asking, so how long do you think it'll last? And I says, well, how many samples do I get? Kind of thing. And what do you know and don't know? How does it fail? Those kinds of questions. He goes, well, we just have the one. You can have it and go away and test it and let me know how long all of them will last. I'm like, wow. And the process of handing it to me, we, air quotes, dropped it. And it shattered all over the floor.
Oh, God.
I said it'll last about 3 feet. And this is a portable product.
Yeah.
They didn't invite me back. But it's, you got to know what you're trying to answer. What's the question dealing with, and the stresses and forces that you're expecting to see. Those are the starting points. And then there's just a world of different techniques and equipment and test conditions and so on that may or may not be useful for that particular thing. I find most people in drop in vibration, get pretty creative. in the lab to create the damage, the style of forces and strains and stresses and impulses and so on, in order to get a clean picture of what's going on. It's not as trivial as throwing on a vibration table for 6 hours and saying it's good. It rarely, if ever, works that way. So as you get started in it, good luck. Make sure your dentures are on tight, because it can get loud. It can get messy. Sometimes it is bone rattling.
Yep.
So with that, I think if you've got a question, this was a simple question. We didn't get a lot of context in it, so that always helps when we do. If you've got a question, if you're getting started in a new area that you don't know a whole lot about, we may be able to help you with some ideas or references and so on pretty quick, get you going. And it makes a good topic for us to talk about to help other folks that are also getting started, say, for example, in vibration and shock testing. So let us know. Head over to accendoreliability.com/go/SOR. And there you can find a couple of ways to get in touch with us. Chris and I and the other hosts of the show are available through LinkedIn and our About pages. So plenty of ways for you to get in touch. I don't have any experiments set up for today. Maybe I'll go do some wood chopping, see how much shock vibration I get in my elbows.
Yeah, as long as you pass the test.
Yeah. As long as we can still wake up in the morning, it's good. But anyway, thanks for entertaining that hopefully intriguing enough question for you there, Chris.
Definitely.
All right, cool. We'll talk to you again soon.
No worries, Fred. Look forward to it.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.